All right, tomorrow we're going to start talking about solutions to quadratic functions that do not have x-intercepts, which is the case here. And so we would say that this one has no real solutions because it has no x-intercepts. But that doesn't mean that it doesn't have solutions, all right? Since it doesn't have real solutions, it's kind of like when you're a little kid and you didn't have any friends, you had imaginary friends. So this one has two imaginary solutions because it does not cross the x-intercepts. In order to work with or determine the imaginary solutions, we need to learn about imaginary numbers, which is a different part of the number system. And here's what we'll be looking at. If I have a function who has no real intercepts or no real x-intercepts, all right, what I can do, I can still write it in vertex form. So I know my vertex is my minimum point, which goes to 3. So I would say x opposite of 3 is negative 3 squared, and my y coordinate is 1. So if I wanted to find my solutions, I would set it equal to 0. So I would say x subtract 3 squared plus 1 equals 0. And when I do that, I want to solve, so I want to isolate the x. So I need to eliminate the 1, so I would subtract 1 from both sides. The 1's eliminate on the left. So that would give me x subtract 3 squared equals 0 minus 1 is negative 1. And then I would need to get rid of my exponent. So to get rid of my exponent, I would need to use a radical, because a radical eliminates the exponent. If I do it on the left, I got to do it on the right. So that would give me x subtract 3 equals the square root of negative 1. And if you put that into your calculator, you're going to get an error. So that means we need to be in math mode 2 because mode 2 deals with complex numbers, which is what we will discuss later. Alright, so let's go to the next slide. Alright, here are our imaginary numbers. Remember, anything to the 0 power is 1 even if it's imaginary. Alright, I to the first power is I, and that equals the square root of negative 1. I squared is negative 1. Anytime you have I squared, you can substitute the value of negative 1. And then it starts going, I cubed can be written as I squared times I, so that would be negative 1 times I, which would be negative I. And I to the fourth is the same thing as I squared times I squared. So negative 1 times negative 1 would be positive 1. And then you can just continue on following the routine there. Alright? So if I used mode 2 in my calculator, because that is the complex mode, alright, and I put the square root of negative 1 in my calculator, it would tell me that it equals I, because the value of I is the square root of negative 1. If I put the square root of negative 6 into my calculator, and my calculator was in mode 2, alright, that calculator would tell me that my answer is 6I, because the negative gets the I, and the square root of 36 is 6. So we'll take that and remember that. When we have complex numbers are simply two numbers added together. The first number is going to be your real number. That's any number that we've worked with so far. And the second number is going to be your imaginary number, and that's any number with an I. I stands for imaginary. So we'll be working with complex numbers when we solve these quadratics that have no real x-intercepts. Alright, so we want to be able to do certain things with them. And again, if you're in mode 2, you can simply put it in the calculator. But just remember, it's just like any other variable. If I want to add and subtract my complex numbers, I want to add my like terms or combine my like terms. So I would combine my 3 and a 7 because they're my real numbers, and that would give me 10. I want to combine my 2i and my 5i because those have the same variable, and that would give me positive 7i. So when I add the two complex numbers, 3 plus 2i plus 7 plus 5i, my answer would be 10 plus 7i. And you can follow the same procedure when you subtract. This tells you that you want to subtract them because there's a minus sign. So we combine or subtract our like terms. 7 subtract 10 would give me negative 3. And I do the same thing with my imaginary numbers. 3 subtract 5i would give me negative 2i. And again, if I put that in my calculator, it would give me that answer. But not only can we add or subtract complex numbers, We can also multiply complex numbers, again, following the same rules that we followed with binomials when we were multiplying them out to get standard form. All right? So we're going to take our first factor and we're going to put it on top. 3 on the first box and 2i on the second one. And we're going to put 7 and 5i on the left-hand side because that's in the second set of parentheses. And we just simply multiply to solve this. So I multiply the 3 on top times the 7 and get 21. I multiply the 2i times the 7 and get 14i. I multiply the 3 on top and the 5i and get 15i. And then I multiply the 2i times the 5i and I get 10i squared. Now remember that I squared actually has a value. I squared is equal to negative 1, so that would be the same thing as 10 times negative 1, which would equal negative 10. So when I'm combining my like terms, I can combine my negative 10 and my 21 because they're my real numbers, and that would give me 11. And then I can also combine my imaginary numbers, 15 and 14, and that would give me 29i. So if I multiply 3 plus 2i times 7 plus 5i, I would get 11 plus 29i. Then I want to be able to do the same thing in this last example, so I'm going to put 7 plus 3i on top and 10 plus 5i on the left-hand side. And I'm going to distribute or use the area model. So I multiply 7 times 10 and get 70. I multiply 3i times 10 and get 30i. I multiply 7 times 5i and get 35i. And I multiply 3i times 5i and get 15i squared. And again, don't forget that I squared is equal to negative 1. So that would be the same thing as 15 times negative 1, which would be negative 15. And to get my answer, so I want to combine my like terms, so I combine my real numbers first. If I combine 70 and negative 15, that's going to give me positive 55. And if I combine my imaginary numbers, 35i and 30i, that gives me 65i. So the product of 7 plus 3i and 10 plus 5i is 55 plus 65i. And we're going to work more of those in class tomorrow. So make sure you took good notes, and hopefully we'll get through with it quickly.